Greetings and welcome to Unit 4 of Week 2, which is related to program outcomes PO6, PO7, and PO8. In the earlier unit, we explored the nature of program outcomes PO3, PO4, and PO5. And in this unit, we understand the nature and importance of program outcomes PO6 and PO7 and PO8 to a graduating engineer. Okay, compared to PO1 to PO5, PO6 to PO11, these 6 outcomes are labeled as professional outcomes or generic outcomes. This has nothing to do with a particular discipline. Every engineer in whatever position is going to work in, whether as a designer or whether the implementer or a manufacturer, in whatever position he is in, these outcomes will have to be met, and he has to operate within the framework of these 6 outcomes. The knowledge, skills and attitudes acquired through addressing these 6 outcomes are required by all professionals at all levels. While no one has any dispute with the desirability of these outcomes, the design of curricula does not reflect their importance adequately at all. Everybody agrees they are desirable, but I can't do it through my course. You do it through something else. That something else has never been defined in majority of the curricula. Integrating them into curriculum and designing related assessments require considerable coordinated effort by the faculty. That's why the curriculum design that addresses and implements to attain all the 11 program outcomes is a huge group activity of the department. All faculty will have to participate and they have to own it also. You can never say that these 3 courses are only my responsibility. I will teach the way what I consider is the best from the subject perspective. Because these courses are part of a program. Program has to meet some goals. So all faculty are responsible for meeting all these PO6 to PO11. Okay, let us look at PO6. Engineer and the world. Analyze and evaluate societal and environmental aspects while solving complex engineering problems for its impact on sustainability with reference to economy, health, safety, legal framework, culture, and environment. It's a very tall order. First thing is, technology is both cause and effect of societal changes. Okay. Depending on the current requirements, we keep generating new products. And a new product comes into market, it changes the way we conduct our activities. Engineers produce products and services apparently for the benefit of society. But many products have the negative aspects as well. The biggest example is our cell phone. Yes, it creates a lot of benefits, it creates a lot of problems. Both technical, health related and social problems as well. And all of us are familiar with that, what is happening. So, but you can't also kind of, we reached a situation where newer models have to be produced for cell phone for the companies to survive. When you create newer possibilities, it creates its own problems. All of us are familiar with that. So there are societal, health, safety, legal and cultural issues for all products and services, and these are context dependent. what is beneficial in one context may not be beneficial in some other context. A student should experience and understand the relationship of products and services to people and society in variety of contexts. And on top of that, let's say you create a product or a service. For example, uh, tourism. Tourism contributes a great deal to economy, right? So many people get jobs, and it kind of grows, and but you also have a lot of negative aspects. First of all, you anywhere you go, travel and go on a tour, you create a tremendous amount of pollution, in physical pollution as well as otherwise pollution. And pollution doesn't lead to sustainable development. So how do you compromise these two? People have been attempting to create such activities where your tourism should not create more pollution, or eco-friendly tourism they call it, but they may not be very popular with all people. So you have a very conflicting requirements for when you look at tourism and try to create products for that. Students should understand the impact of engineering solutions on people and environment. Students should demonstrate the knowledge what can lead to sustainable development. And here uh, one should be familiar with, because at the international level, ENO has identified what you call SDGs, Sustainable Development Goals, and there are 17 of them in all aspects of life. And one has to look at, for whatever activities that you are involved, a specific engineer is involved, which SDG is relevant. Are you able to operate or plan your own career which does not violate that particular SDG? And also at personal life, which SDG is you are likely to what do you call violate? Right? For example, in our way of life, the way we use our plastic, the amount of energy that we use, or the way we travel, are you what do you call not help in meeting those SDGs? Okay. Now the only way, first thing is students have to be aware of what is the impact of engineering on the world. So case studies can be incorporated in some courses that will bring the attention of students to product, service, people relationship in a number of contexts. Assessment should be in terms of the student's perception of his responsibilities. It is possible to collect case studies and create some kind of exercises around those case studies and be presented in some courses, and the whether the students have become sensitive or not uh, can be can be measured through appropriate rubrics. The evaluation rubrics for projects can incorporate elements of engineer world interaction. There can be actually courses offered which are possible. Resource information is available. Technology society interaction like energy and society, water and society, complexity, housing, climate change, and sustainability to address this PO. You can have at least one or two of these courses as part of your curriculum, which will sensitize the students to this issue, PO6. So, some PO6 activities Understand the goals and working of relevant professional society. Professional societies do make available, and those goals and working of these professional societies can be brought into the curriculum. Identify when and where engineers interact with society through their professional activities. Understand the responsibilities implied in one's professional practice. Case studies and courses on technology and society and sustainability. Case studies can be incorporated in some courses that will bring the attention of the students to sustainability issues. Assessment could be in terms of the students' perception of impact of engineering solutions on sustainability. One thing is any kind of convenience that we use, like let's say ordering food on through Zomato or any other such app. What it's a convenience, all right, but what are you doing to the environment because of that? If you are sensitive, can you create a balance with respect to your convenience and pollution? If that sensitivity can be created, yes, we are addressing PO6. So, some sample activities that you can incorporate into some course or through designing specific courses. Analyze and design systems such as wind turbines or solar panels, evaluating their socio-economic benefits and cultural acceptance in different regions. One solution doesn't fit all, never fits all, because in different regions, in different societies, they will have different impacts. Can we be sensitive to that? Study the interaction of renewable energy sources into power grids, assessing impacts on environment, economy, and energy security. Conduct audits on electrical systems in buildings, developing strategies to improve efficiency while considering cultural and legal contexts. Okay. Some more samples. Develop systems to minimize industrial emissions, evaluating economic, health, and environmental impacts, and ensuring compliance with legal standards, and so on. I will not read through the other. Okay, coming to the PO7, which is ethics. Now, today, practically all organizations, big corporates, at least on paper, they expect all their employees to behave ethically. They will explain to you when you join in the organization that these are the ethical requirements you have to meet. So, to that extent, before you go for employment, if you are sensitive to that, then you are likely to get employment first. Apply ethical principles and commit to professional ethics, human values, diversity, and inclusion. Adhere to national and international laws. These are the what do you call PO7 requirements. Now, application of ethical principles requires what you call moral autonomy. A moral autonomy means conduct and principles of action are owned. It is not just a repetition of a statement on a piece of paper or remember something and reproduce. You have to own you should have the responsibility. That is, I am making my decision ethically means that I own my decision making. I do not transfer that response. You cannot say somebody asked me to do it, I have done it. That is not moral autonomy. Okay. So the decisions and actions are based on critical reflection and not passive adaptation of some code. And moral beliefs and attitudes are integrated into the core of one's personality and lead to committed action. You will have enough number of reasons why you are doing, why you have done what you have done. But that is not moral autonomy. Okay. So this is not an easy decision to make for majority of the people. But whatever decision you have made, you have to own that decision. You got to have your own explanation for it. You have to be convinced of that, and you have to take the responsibility. Whatever consequences that come, you say yes, you are willing to take that. That is moral autonomy. Professional engineering ethics are rules and standards governing the conduct of engineers in their role as professionals. Every professional engineering society will define a code of ethics for its practitioners. So, faculty will have to get access to those codes and find out where exactly they have to be introduced to the students. Students should understand the nature of ethical problems they face in engineering practices. Students should understand the ethical norms of engineering practice and their implication on professional decision making. PO7 can be addressed through dedicated course on professional ethics and or case studies with focus on ethical issues and their resolutions. Courses are available. You can offer a full-fledged course on professional ethics. Some institutions have actually done that. And sometimes boards of studies, they get tired of that and remove, and some people bring it back. So we are very ambivalent about incorporating into the curriculum. Or at least you can bring the case studies if not a full-fledged course. For example, some of the activities that can address PO7 identify the deviations of an engineering solution from the accepted professional practice. There is a standard and there is a particular engineering solution that is created. So you can expose the students and ask them whether they can identify the deviations of a particular solution from the official professional practice. Identify the impact of an engineering solution on different groups of persons. Recognize the ethical dilemma in the case study presented. Propose actions that minimize the damage and synthesize solutions rather than judge the players in ethically complex situations presented as case study. So don't fix the blame on individuals, but can I propose actions that minimize the damage and synthesize such solutions. So some sample activities that can be incorporated. Analyze real world scenarios involving mechanical system failures, discussing the ethical responsibilities and decision making process while considering human safety and legal implication. Let me give some other example. Design algorithms with focus on ethical implications, addressing bias and data privacy to ensure fairness and respect for human values. This is now the most dominant one, with AI dominating every aspect, and it is very dangerous also to make quick decisions and incorporate. And there is a whole lot of people arguing about it, and the companies which try to popularize AI, they are in a hurry, but they also have their own ethical boards and they say they are meeting that requirement. But the company itself cannot make decisions for themselves. It is other agencies which will have to find out what should be done cannot be done. If those of you are interested, there is a book called Focus by Yuval Noah Harari, which brings out all the issues related to, particularly with regard to AI, or the kind of networks that we have been creating, what its implications can be. Work on projects designing infrastructure solutions for underserved communities, considering ethical implications and respecting cultural diversity. Conduct risk assessment for chemical processes, emphasizing ethical responsibility towards environmental sustainability and public health. Particularly anything related to chemical units will face so many issues related to what they release to the environment, what kind of chemicals they are producing, what kind of byproducts they are releasing into the environment, and so on. Now coming to PO8, individual and teamwork. Let me read the statement of PO8. Function effectively as an individual and as a team member or a member or a leader in diverse multidisciplinary teams. First of all engineering activities in any organization are group activities, right? There is nothing like one individual is responsible for one product or one service. Groups of people are involved. When it is a group activity, it's a teamwork. Multiple number of people are involved in that particular activity. You are working as a team. That means every professional is a member of a team. So you have to be a good team member. And there are goals for any project, either developing a product or providing a service on a product. You are always working as a group. So the group itself will have some goals. You cannot have your own goal for that. In a what do you call negotiated group goals, you have to accept that negotiated goal and you have to operate within that. That means one person cannot do, different people and the group will do different parts of that activity, and all of you have to work together. When you are working together, you have to share whatever you are doing with the group, and you have to do it in a commonly accepted manner. Okay. So, ability to work in a team is a very important activity for all organizations. So, any program should train people to work in a team. That means the program, the department will have to offer experiences of that kind where you are working in a group. Where do you do that? How do you do that? For example, you have a project where you work in a group. Just saying that these 4 people work on a project alone is not sufficient. You have to ensure the project will have to be orchestrated, that they have to work together, they have to share the work, they have to address a common, they have to work towards a common goal. That is one part. And you can also incorporate group assignments in some courses, which will be of smaller scope, but which will lead to interaction among the students. So, for example, an individual after becoming a member of a team and identification of his or her role should be able to work effectively to achieve the team's objectives despite personal differences with other team members. Two individuals will always have difference of opinions how to go about working, but you have to quickly come to a common understanding that this is the way we work together. This is their respective roles. If you cannot learn that, obviously you do not become a good team member, and every organization a, um, expects their employees to be good and effective team members. Because if you are not an effective team member, the whole it becomes an expensive thing for the organization. You take more time to reach your goal. You spend a lot of your energy on taking care of individual differences. So everyone will have to train themselves as a good team members. You cannot say I am a good team member but the others are not. You cannot take that kind of position. It is necessary to develop rubrics to measure how good a team member one is and to make that evaluation count. So if one is not a good team member, you have to give less number of marks or a lower grade for that. The student should be provided with experience as members or leaders in technical, semi-technical and non-technical teams. It is worthwhile to arrange coaching students on becoming members of the teams. There are programs available, short programs, how to become a good team member. What are the activities of PO8? Group assignments that involve group decision making, division of work through negotiations. For example, when you go for an interview for selection to a particular job, they have group exercise, group discussions. So somebody will observe you, how you are member of a group. You cannot be passive, you cannot be dominating either. So they will mark you for that, and if you fail in that, you are not likely to be selected for that. So you can have group projects, co-curricular activities that will require a group, activities through e-groups. These days e-groups are also have become popular because of the technology available. You work with people whom you have not met face to face, and still you have to be work with somebody online. So some sample activities: present project outcomes and provide peer feedback, fostering communication skills and constructive critique within a diverse groups. Work with students from computer science, electronics and mechanical engineering to develop integrated systems like smart home solutions, emphasizing teamwork, leadership and effective communication. Assume leadership roles during laboratory experiments and demonstrations, coordinating activities and ensuring team goals are achieved. So I will not read through all of them. Join teams with backgrounds in environmental science and manufacturing to optimize chemical processes, fostering cross-disciplinary communication and leadership. So what these sample activities represent, you have to particularize to the course or to the program and make sure the students do participate in that, and they are evaluated for their effective participation also. Okay. So we looked at the PO6, 7 and 8 and what are the possible exercises that can be incorporated. But again, once again, I'll keep repeating that addressing these is the entire all the faculty of the department will have to participate and come with exercises. In the next unit, we will try to understand the nature and importance of program outcomes PO9, PO10 and PO11 to a graduating engineer. And thank you for your attention.